All right, so I'm going to work on the homework assignment that was due today. If you have turned it in and you think it's working 100% already, you don't really have to pay much attention to me. On the other hand, if you just want to see how I work on the problem itself, it may not be a bad idea to just to listen in and just kind of think, see how I approach this particular problem. Okay. So I'm going to start with Mastermind scoring because I did not keep the folder from the other homework assignment, so I'm going to start with this one. And use only one window to do it. I do have Mastermind. It's not a folder. Yep.
By the way, I'm Spencer. I was wondering about Math 55. It's discrete mathematics.
Okay.
What kind of class is that?
You mean cisp 440?
440, yeah. That's
okay. The long way to find out is to watch the video recording of that class because that semester is almost done and I covered most of the material for that class already. But for the most part, I talked about distribution of probability, discrete probability. I talked about recursion, ways to prove theorems, predicate logic, propositional logic, and that sort of thing.
Is it a fun class?
That is a very subjective question which I cannot answer. It was fun to teach. I'll put it that way. But the recording is online, so you can kind of check out, just spot check a few days, just to see the kind of topic that we go over in that class.
Thanks.
But it's not a math class though, so it will
not a math class.
I don't think it will meet any of the math requirements. It is CISP 440. All right, so getting back to this one, I'm gonna so mm.cpp is already posted online for those of you who want to download it. This is one way to do it. And I'm just going to download it directly into the folder itself. Oh, that's because I started this command, terminate it, place it. Okay, there we go. And then the next one is Mastermind playing, which is the homework assignment due today. File. Does anyone remember where I put the make file?
The original first mastermind game, isn't it?
Oh, the first one? Oh, it has a link in it. Okay.
Yeah, it's like at the very bottom.
Okay. going to adjust the makefile to include mmgame.cpp. And split the screen here. mmgame.h on one side, mmgame.cpp on the other side. So this way I can keep track of the subroutine that I'm supposed to implement and also the actual subroutines on the other side. Yeah, it wraps around and it's a little bit hard to read. In VR, you can say do not wrap. You can say set no wrap, I think. And so it does not wrap around, which is good because it doesn't give you the wrap around text, but on the other hand, it's kind of hard to get to the other part. You actually have to cursor over to display, to let it scroll and display the other parts. So we'll do it this way, at least for now. So pound include mmgame.h, and then we'll go ahead and implement mmgame generate hidden struct mmgame pointer to the game itself. All right. So this is supposed to use random, okay, and we have to use the right number of pattern too. So we say for int I equals to 0, I is less than pattern length plus I, and then for each iteration we take care of one position of the hidden array. So we basically say PG refer to the hidden array in the structure with element I equals to a random number. I think it is just random, but then we have to mod it with the number of colors. So I cannot remember the variable name for that one, so I'm going to go back to mm.h. And it is number of colors. So that will make it number of colors. And just want to make sure that random is called this way. So random has no particular parameter, has a long int return value, so that should be it. Okay, so there we go. So are there any questions about the implementation of mmgame generate hidden? Yep.
Random will always, every single time you run it, it will always be the same number every
Yep.
time.
That's what we said. That's what we said in the class because it uses the same seed every single time.
Okay.
Now, if you want to make it a real game, you have to reinitialize the seed when you start the game. But you have to find something that is different every time you run the game. And most people use the current timestamp to initialize it because the amount when you start the game is quote unquote typically unpredictable.
Yeah.
Yep. All right, so that will take care of the first one. And I'm going to take care of the second one, which is also easy, which is game reset. So game reset is going to take the same kind of pointer, which is a struct mmgame pointer. And what it is supposed to do is to change the counter within an mmgame back to 0. And the counter is guesses used. That's the only integer in the entire structure, and that's the one that I need to use to reset it. So pg dot guesses used, which is a counter, and just reset it back to 0. That's all we need to do is to change it to 0. Do we have any questions about mmgame reset? Yep.
I'm kind of confused about like the different files and stuff. Like, does mmgame.h call the functions and then .cpp defines what they do?
Okay, mm.h is going to tell everyone how to use the structure and how to use the subroutines. Okay, but it doesn't say exactly how it is done. The .cpp file has the definition of the subroutines. So how the subroutine is done is in .cpp, but how to use it is in the .h file. Is that okay? Sort of? All right, so now we have the next one, which is mmgameGuess. Okay, so int mmgameGuess, it will take a game structure pointer and a guess. So guess. If I remember correctly, that's the prototype. This is the problem when I turn off the wrapping text, so it will actually take some scrolling to find out what is the other part. Yep, it is a guess. Okay, this is the big one. This is the one that is more complicated. It will check, to see if there's room. I'm trying to find out, how to best display this one. So I'm gonna do XA, and then this time I'll do a dash little o. So this will open it up, top and down, which is easier to read when I have those long lines of comments. Okay, so game guess should check to see if all the guesses are used. If so, return the value of 2. All right, so to implement this, that's the first thing I will check, because according to the comments, this is the first thing we should do. So we'll say if PG, which is a game, when we dereference it, it becomes a struct game again, and we'll use guesses used as a number to compare, and we'll compare it to the constant that defines the number of guesses we can actually make, which is here, game length. So we'll compare this to game length. If it is greater than or equal to, that means we have already used up all the guesses. And according to the comment, it says return the value of 2 in this case. Okay, so we'll go ahead and, so you have 2 ways to do this. You can either say return 2 here, which is not exactly a good thing to do in general. In this case, it may be okay. The other way is to declare a local variable called result, and then you just say, okay, result in this case is 2, and make sure that we have a return result at the end. Now we have to specify the else, which basically is saying, okay, what if I have not used up all the guesses? When guesses used is less than game length, I still have a spot to put a new guess. So this is what we need to do next. In the description in the comment, starting on line 15, describes what if there is still room for another guess. So I'm going to scroll down one more line, and it says right here that we have to first score the guess pointed to by p guess and copy it to the appropriate entries. Okay. So the way to do this is to call score, and the first one is going to be the hidden pattern. The hidden pattern is a part of the structure pointed by PG, and the member name is just hidden itself. Okay, and this is not going to work. Okay, so I'll explain how to fix this when the compiler complains about it. But at least we'll be addressing the right member. The second thing you have to pass to it would be the guess itself. And because pguess is already a pointer, and score is really just expecting a pointer to a guess structure, that will work out just fine. Are we doing okay so far with this part, which is corresponding to guess should first score the guess pointed to by pguess? Is that okay? The next thing is to do. The next thing we have to do is to copy it into the array, which is called guesses. So now we will do something like this. So we say, okay, this is a game. In game, guesses is an array. So now we have to figure out what index that we are supposed to use. We do have a counter called guesses used that is counting the number of items being used in the history in guesses. But we have to be careful because this is before we actually increment it, so that means it should be reset to 0 at this point. As the first element, we just use it by itself, and then we increment it later. So, so we basically say PG, dereference PG to get to the game structure, and then within the game structure, we are going to use guesses used as an index. And there's nothing wrong with this approach. This will work just fine. Because the left-hand side is going to specify a struct guess, and then the right-hand side is also going to specify a struct guess, so this assignment operation will work just fine. Are there any questions about this particular line, line 26? Did anyone do this, or did you guys copy individual members? Okay, you did it this way? Okay. All right. And then the last thing we have to do is here, the guesses used counter should also be updated. Since we have one more entry in the guesses, we just have to change it by one. So we add one to oops, guesses used, and that will handle all the cases. Now we have to specify the return value. If the guess pointed to by pguess matches the hidden pattern, return a value of 1. How do we know that? Well, we just came back from MM_score. MM_score is going to specify the number of black pegs. If the number of black pegs matches the number of pegs in a pattern, then it will satisfy the requirement to return the value of 1. So that's what I'm going to do here. So I would say, let's check what pguess is pointing to, and we'll compare the number of black pegs that I got as a score to the length of a pattern. If it does match exactly, that means I can now return the value of 1, otherwise I return the value of 0. Since I do not like a return statement inside a conditional statement, I use result equals to 1 here, and I use return result later on. And this one is going to return the value of 0. And I think that should do it. Okay? Are there any questions about this part? Well, let's give it a try, right?
You didn't increment
I thought I did.
oh, yeah.
I slipped it in when you were not watching.
Okay.
Any other questions? Okay, let me get rid of the first split screen just so that we can look at the entire code a little bit easier this way. And that's still not displaying quite the way I want it, so I will change the font size so that we can at least see the entire code. There we go, I think that's a little bit better. The window a little bit longer. And that should do it. There we go. Are there any questions about MM game guess? About the implementation or the definition of it? Yep.
You said the first parameter for MM_score, you said that wasn't going to work?
Correct. So I'll let the compiler complain about it, and then I'll explain how to fix it. At least one person found that it does not work the way it is right now. So we'll say make. And it complains about random. Oh, that's because I forgot to do the pound include of random. So I cannot remember where it is, so I man it. And we have to do a pound include stdlib.h. Okay, so there we go. And it is in mmgame.cpp. Pound include stdlib.h. And we'll do make another. It actually worked okay.
Yes.
So I do not understand why the other person had a problem with it. That is weird. Okay. All right. So now that we have it running, we'll go ahead and play the game. This time I am the one guessing, and the computer is the one that is hiding the pattern. Okay. Most of you probably know what the pattern is because random keeps giving you the same number over and over again. But since I do not remember that pattern, I'm going to actually play the game. So we'll start with 0, 0, 0, 0. Okay, 1, 1, 1, 1. Okay, 1, 1, 2, 2. Okay, and we'll try 3, 1, 1, 3. That's cool. Hmm? Oh, can I? Oh. Okay. That's because of the projector setup. There we go. Okay, I think the first number is the number of black pegs. No, it cannot be. The first number? Let me double check.
Yeah, first number is black.
The first one is black?
Because on the 1111,
Uh-huh.
you'd have two black pegs, right?
Oh, okay, right, that makes sense. Okay. So 3113 has three that are positioned right, but they're all wrong in terms. Three column right, but position they're all wrong. So that means it has to be 1-1 on the extreme side and then 1-3 in the middle somewhere. So 1-3-2-1. Oh, that was stupid. I have already tested all the twos. You know, why would I do something about the two? Okay, so I know the 1-1 is right, so it has to be 1-4-3-1. Is that kind of consistent with your pattern? Well, it might be different depending on how you initialize the array. Not everyone initializes the array from the beginning to the end. If you initialize it from the end back to the beginning, then you would have 1-3-4-1 as a pattern. It depends on how you do it. There are different ways to do it. All right. So I'm gonna post my solution. Do you guys want to test it anymore? I mean, it's good. All right. If this is good, I'm gonna post my solution so that anyone who wants to use it can use it as a starting point. Alrighty. So the solution is now uploaded. Are there any questions about the key, the solution? Alright. So if there are no questions about the solution, I'm gonna stop the recording.